Alright, the one big thing, if I ask you to solve by factoring, here's the most important part on this one is, your equation has to equal 0. Now, there's some other things other solving we'll look at later on where you don't necessarily have to do it this way. But if I ask you to solve by factoring, you have to take the equation set equal to 0. All right, if it is not set equal to 0, if it doesn't equal 0, just rewrite the equation, which means you're going to have to add and subtract some terms and move some things to the left side or the right side or whatever you need to do. Just rewrite the equation so it does equal 0. Okay, and this is kind of like, I guess that's the first bullet thing, is just to make sure it equals 0. If it doesn't, then rewrite it so it does equal 0. So that's the first thing you're going to do for all these problems. Second thing, once you've done that, you're just going to factor the equation. And that's going to be the exact same thing we were doing on the second part of the test, where you were, whichever way the factoring was, you basically just took the equation, you factored it out till you had your different sets of parentheses. Okay, now here's, and on the test, that's where we were done. You factored the equation, that was it. Here's where we're going to add the one extra thing to it. Once you factor the equation, you're going to set each parentheses equal to 0. And then you're going to solve that parentheses equal to 0. And the solving equations are going to be really fairly simple because most of the time they're just going to be one answer, one step to the answer where you're going to have to add or subtract. There may be an occasional few problems where you're going to have to do some division. But the solving part is going to be really, really straightforward and really, really simple. Alright, so here's our first example. X squared minus 5x minus 14 equals 0. Alright, so now, and as long as it's equal to 0, you can just ignore this part of it. Now we're going to factor this thing. So you're looking for the factors of negative 14, where the sum is going to equal negative 5. Okay, and with 14, there's only two choices. It's either 1 and 14 or it's 2 and 7. Now, the same thing is going to be true. If this sign is negative, whatever this sign is that's here of the number we're looking for the sum, the B term, whatever that sign is, that sign has to go with the bigger number. And to find the sign of the other number, just divide these two like it was the slope. Two negatives make this one a positive. So the 7 would be negative, the 2 would be positive. Okay, the pair that adds up to negative 5, it's going to be the 2 and the 7. So it's x plus 2 and x minus 7. And on the test, that's where we stopped on the test. And once you had the two parentheses, that was it. That's all you had to do. Here's where we're going to go one more step with each of these. Now it's equal to 0. So then you just take each parentheses and set it equal to 0. And again, the solving here is where it should be really straightforward, because most times it's going to be one step. You'll get some of the problems will be a two-step. This one you just subtract 2 from both sides. And there's your first answer. For this one, you'll add 7 to both sides. And then there's your second answer. Yeah, so again, we'll come to this one a little bit later, but whatever your highest power is that's here, that's going to tell you how many solutions you're looking for. So if you have x squared, you're looking for 2 solutions. If that had been x to the third, you're looking for 3 solutions. So whatever power of x you have that's your highest power of x, that's how many solutions that you have when you're going through these problems. Alright, so let's give you one that's same kind of problem, just a little different look to it. Okay, let's go with x squared minus 7x equals negative 12. Okay, and again, we said back up here a minute ago that for solving by factoring, it has to equal 0. This one doesn't, so the very first thing is we've got to get rid of this 12. So let's add 12 to this side to cancel this one out. So we've got x squared minus 7x plus 12 equals 0. Alright, and once you've got that one, now we're doing the same thing. It's the factors of, in this case it's a positive 12, and we want the sum to equal negative 7. Okay, 12. And again, before you list the other ones, just realize that, again, kind of use this one to get the setup of it. Your sum is negative 7, so the bigger number has to be negative. If you divide a positive and a negative, that makes the other number a negative. So in this case, they're both negative. Pair adds up to negative 7. That's the 3 and the 4. And again, on the test, and this is the difference we're going for this one, is that on the last test we stopped here. When I ask you to solve, got to go one more step. You're going to take then both of these and set them equal to 0. Again, just change the sign here to make that a positive 3. Change that sign to make it a positive 4. Okay, so still the same thing we were doing on the last test. You're still factoring. The only difference is now is that when you get to the end of it, just do that one extra little bit of work so that you can set each of those parentheses equal to 0. And we'll go from there. Okay, so that's your two basic ones. Now, what I'm going to do for the next 3 or 4 is just show you some of the different problems, because you'll have all those special cases and we've got all those different things we've got to do. So let's just show you every other kind of problem you could see factoring-wise, so that you at least seen it one more time before we get through this. Okay, so for example 3, we'll go 9x squared minus 25 equals 0. And with two terms, there's only one of two things it can be. It's either you've got a greatest common factor, which in this case, there's nothing in common with 9 and 25. There's nothing you can divide into both those two numbers. So if there's not a greatest common factor here, and it's two terms, it's one of those special cases that we were looking at. And it's okay that those are both perfect squares numbers. Because 9, you can make it 3 times 3. 25 would be 5 times 5. So for this one, we're going to do the perfect squares shortcut. And if you square root 9x squared, that would be 3x. And if you square root 25, that would be 5. Okay, so to get 9x squared, we need a 3x and a 3x. So that 3x goes first in both parentheses. The second number you've got here goes second in both parentheses. And to be a negative 25, if this one's a negative, that one's got to be a positive. Okay. And remember, if you're perfect squares, that's 4, 9, 16, 25, 36, 49, 64, 81. All those numbers you would just do, 2 times 2, 3 times 3, the same number times itself. If you've got one of those numbers that pops up, that's your perfect squares you're looking for. Okay, and then from here, just set them both equal to 0. So this one, we would add 5 to both sides, and then divide by the 3. This one, you would subtract 5 from both sides, and then divide by 3. And that perfect, if it's the two terms, the perfect square shortcut, it's always going to be the same two answers where one's a plus and the other one's going to be a minus, because that's the only difference in the two parentheses, is that one has a negative and one has a positive, so that's going to be the only difference in the answer, is one's going to be a negative and one's going to be a positive. Okay, so anytime you've got the two terms, that's shortcut that you're looking for, that it could possibly be there. Alright, halfway there. Alright, let's go with 4x squared. Let's go plus 5x minus 6 equal to 0. Okay, there is no greatest common factor, so we cannot get rid of the 4. So for this one, this is where we're going to have to do the bottoms up, which was that worksheet that we had the other day. So you got to multiply these two together. So 4 times negative 6, that's a negative 24, and that's what we're looking for the factors. And for that one, we want the sum to be positive 5. Okay, and again, most of the time it's not going to be 1 in the number. Occasionally that one will sneak in, just depending on how the number's set up. Most of the time it's not that one. So when you do this one, the biggest thing for this one is get the signs in the right place. That b term is positive, so that number's got to be a positive. And then if you do like slope, negative over positive makes the other number a negative. Okay, so there's all your factors of (24). And again, first, biggest number is always positive, smaller number is negative. The pair that's going to add up to 5 will be those two. Now here's where, and again, this is where the book does something a little different than the way we do it. You still get the same answer, but they kind of go a different route. The route we're going to do is what we did last time. Go ahead and write these two numbers down. So we've got the x minus 3 to x plus 8. What do we do different? Here, what do you have to do extra on this one to get the numbers to be what it needs to be? Got to do one little thing here. Everybody remember? Got something to do with 4. Got to divide by 4, right? Because we multiplied by 4 in the beginning to get this number, so we've got to kind of balance it back out. So go back and divide these two numbers by 4 to balance it back out. Alright, 3/4. That one doesn't simplify, so you're good there. 8 divided by 4 is 2. Okay, now I'm going to go ahead and show you all the steps. There is a shortcut to this one, and if you want to come ask me about it later, I'll show you that one little shortcut we can do. Go ahead and do the bottoms up, because sometimes I'll show the shortcut and it throws people off a little bit, so if you want to see it by yourself, I'll show it to you, but I'm not going to show it to you as a whole group. And then just take both of those parentheses and set it equal to 0. Okay, the x plus 2. Again, just subtract 2 from both sides. And you've got one answer. This one you have to do one extra step that you do want to add the 3. But then you've got to go back and divide by 4. Let me go ahead and tell you this part. Okay, I'll go ahead and tell you the shortcut. Here's the shortcut you can do. Now, for the 2 that's here, there's not really a big one here. If you get a fraction answer that's here, and if you don't know the shortcut, I'll show it to you. If it throws you off, don't worry about it, because it's not a huge shortcut. It just saves a little bit. Once you get here and you've done the dividing by the 4 and you've got these simplified down, all you have to do, it's kind of like we said earlier, that once you get these numbers, you don't have to do the bottoms up here. If you want to just forget this and just change this sign, because you're going to set this equal to 0, all you're going to do is you're going to add the 3/4 over. That basically you don't have to do the whole bottoms up thing here. You can just change that sign from negative to positive. Same thing we did on this one. You can just change that sign from positive to negative. And some people say, well, didn't we just do it? So it's the same thing. You're just skipping this little bit of work. But if it helps you just to keep doing the bottoms up, then go ahead and write the bottoms up. It only saves just a few seconds, so it's not a huge shortcut. It's just a small, tiny little shortcut. All right, 2 more, and then we're done. Okay, so 3x squared equals 6x for the next problem. Okay, in every one of these problems, same thing. If it doesn't equal 0, you've got to get it so it does equal 0. So for this one, let's move this 6x over here to the left. Now, somebody may be asking, could we move that 3x squared over here? We could, but most of the time, these problems work better if the x squared term is positive. It just seems to make things work out a little bit better. But you could have moved it to the right side and it still would have been okay. Okay, are those perfect square numbers? They're not, right? So if they're not perfect square numbers, what else can we do? Or what do they have in common? Okay, you can divide them, right? So in this case, you've got 3 and 6. Now they both have an x, so let's take out the GCF. So take out the x. 3 and 6, you can divide them both by 3. So 3 divided by 3 is 1. Take out one of the x's, that leaves one of the x's in there. 6 divided by 3, there we get the 2 for that part. So if they're not perfect square numbers, the only thing you can do, if it's 2 terms, the only thing you can do right now is just take out the greatest common factor. And when you do that, technically, and it's not written this way, but technically that 3x is in parentheses, so that would be 2 sets of parentheses. So then you can set the 3x equal to 0, and then do the x minus 2 equal to 0. Divide by 3, doesn't matter because you have 0. Doesn't matter if you take 0 and divide it by 3, it's still just 0. For this one, we would add 2. Get x equals 2. And again, the degree was 2, so you know you're looking for 2 answers. And that's one thing that sometimes helps people out, is that whatever that highest power is, that lets you know that you need 2, so that means you got to have 2 solutions. And we'll actually talk about that a little bit later on, but that's the degree. The degree is the highest power of whatever equation you're working with. So we'll go ahead and throw that out there because I'm not going to talk about it yet, but it's coming soon. So the more times we mention it, the easier it gets. All right, last one of the day. We'll go with 49x squared minus 126x plus 81. Okay, there's not a greatest common factor. because there's nothing you can divide into 49 and 126 and 81 because there's just not much there. And some people will look at it and they'll think, well, okay, then that means I've got to do the AC method. Well, if you did that, here's what you don't want to do, because you don't have to write this down. If you multiplied 49 times 81, that would be 3,969. I don't want you breaking down 3,969. At that point, there should be that little light bulb going off in your head going, wait a minute, that's a big number. Do the perfect square shortcut. Because I'm not expecting you to sit there and break down 3,969. 49 is a perfect square root number, or sorry, perfect square number. If you take the square root of 49, that's 7x. If you take the square root of 81, that's 9. So anytime that first and last term, if it's 3 terms or if it's 2 terms, if it was this number, if it was, 49x squared, minus 81. Anytime that first and last number are perfect squares, start seeing if there's a shortcut. So in this case, we'll do it. So we've got 7x goes first, and then the 9 goes second. Okay, now, here's where this one's a little bit different than the 2-term one. In the 2-term one, we had one that was plus and one that was a minus. This one, because that last number is a positive 81, if we do 9 times 9, if we did a negative 9 times a positive 9, that would mean this would be a negative. But since this one is a positive, they're either both positive or they're both negative. And how you know which one's which is, basically you just take the middle sign. If that middle sign is negative, then they're both going to be negative. Now, the good thing about this one is you don't have to set both of these equal to 0 because they're both the same set of numbers. So once you do that, you can just solve one of the equations or one of the parentheses, and then we're good to go. And if somebody's saying, well, we just said a minute ago that if this thing is x squared, we're going to have 2 answers. It's the same answer, it just repeats twice. So that's where, because again, if you do this parentheses, it's the exact same answer. And just like when we did the main range before, if the same number showed up twice, you didn't have to write it twice. You could just write it once and it would be okay. This one, it's kind of the same thing. It's still 9/7 2 times, but you only need to write it once because it's just a repeat.